Okay, guys, in today's lessons, we're going to visit about trapezoids. Before we get into properties that exist with the trapezoid, the first thing I want to do is I want to identify the pieces that make up a trapezoid. What we have right here is we have two sides of this of the trapezoid that are opposite, that are also parallel. Those two sides are called your bases. So this is a base here, and this is a base right here. The other thing that we have is the sides that are not parallel. Those guys are called the legs. So that's a leg right there, and that's a leg right there, okay? The other thing that we have is we have base angles. Now, this angle right here and this angle right here, or my blue angles, so to speak, are base angles. Also, this angle up here and this angle up here, or the red angles that I have right there, those guys are base angles as well. But when you're talking about them together, the red one and the blue one together are not base angles. So when you talk about base angles, you're talking about two at a time, and it's this guy over here. These two are base angles, and these two are base angles. Okay, the main idea or the main properties that exist with a trapezoid, your basic idea is this. Number one, it's the definition of a trapezoid. So what is a trapezoid? Definition tells me this. It's a quadrilateral with exactly one pair of opposite sides parallel. So there's the definition of a trapezoid. Okay. The only properties that go with it, if we labeled this guy, and I called this A, B, C, and D. The only other thing that you know about a trapezoid, okay, nothing special about this guy, is that angles A plus angle D, when you add those two guys together, those equal 180 degrees. And if you add angle B plus angle C, those two guys together equal 180 degrees. Okay, so again, properties of a trapezoid, I know that there's exactly one pair of opposite sides are parallel. And I also know that this angle and this angle together are 180. This angle and this angle together are 180. And when we get a little bit more specific right here, now we're talking about an isosceles trapezoid, okay? If you recall from when we were dealing with triangles, we had an isosceles triangle, and the definition of that was at least two sides are congruent. When we're talking about an isosceles trapezoid, it's the same definition applies. I've got exactly one pair of opposite sides are parallel, and now the legs, in this case, are congruent, okay? Nothing changes here as far as my angles being 180. Angle A plus angle D still equals 180 degrees. And angle B plus angle C still equals 180 degrees. We do have a little bit of a difference, though. Now when I'm dealing with an isosceles trapezoid, and I draw out my diagonals right here, what we come to find out is that actually the diagonals themselves are congruent. So AC is congruent to BD. The entire length of the whole thing, they are congruent. Okay? And we've already talked about the fact that the legs are congruent. The other thing that we know is this. If I'm going to make marks of congruency on the diagonals, they look like this. The top two are going to be the same, and the bottom two are going to be the same as well. The last thing that we have when I'm dealing, and this is only with an isosceles trapezoid, guys, is that base angles are congruent. So angle D and angle C are the same. So I'll write that over here. Angle D is congruent to angle C. And also, angle A is congruent to angle B. So there's all our properties together right there. Now, how are we going to use these properties to solve some problems? Let's put it to task. First thing that we have right here is we have trapezoid ABCD. It's an isosceles trapezoid. So again, you can put a whole bunch of marks in there. But since we're talking about angles here, this is angle BAD. So where does that exist? Here's angle BA and D, and angle CDA. And here's angle CDA. Well, what do we know about this angle here and this angle here? Hopefully you know this, or you recall this from just a second ago. Those two angles are the same. And because those two angles are the same, then because of the information that we have, we just set them equal to each other. So in this case, we'll go there I have angle BAD, which is 4x minus 45, and I set it equal to angle CDA, which is 2x plus 15. Go about the process of balancing the equation. And we find the value of x to be 30. So with that said, what can we do with this? Well, we know both of these two angles are the same, okay? Now we're actually asked to find the measure of angle ABC. So it's this angle up here that we need to find. Because if we solve for x right here, I'm going to plug it into one of these two angles. Here's angle A right here, well, that's angle BAD. So if I put a 30 right here, what do we end up with? Well, 4 times 30 is 120. Minus 45. So in this case right here, I'm left with 75 degrees. So this angle right here is 75 degrees. And again, the properties of a trapezoid tell me that this angle right here and this angle right here, when I add them together, they better equal what? Exactly, they better be 180 degrees. So 180 minus 75, and I end up with this. 105 degrees. So the solution to this one, find the measurement of angle ABC, is 105 degrees. Moving on to the next one right here. Again, ABC is an isosceles trapezoid, so we need to identify the things that we're talking about. Look at this. Here's the measurement of angle segment AE and ED. Where are those guys? Well, here's AE and here's ED. And if you recall from earlier pages here, these two segments right here are congruent. So those guys are the same. So with that said, all I need to do is set my two expressions equal to each other. So in this case, 3x plus 20 is equal to 5x minus 4. Again, the process of balancing the equation, solve it up. So we find here that our value of x is actually 12. However, that's not the question. The question is asking us to find the length of AE. So with this 12, I need to come back to the expression that is AE, plug in the value of 12 for x, and then solve. So in this case, we find that the length of AE, or this distance right here, is actually 56. And 56 what? Well, because nothing said, it's just 56 units. Okay, now when we're talking about a trapezoid, we're talking about a median. And basically what that says, if I started off like this, trapezoid A, B, C, D, okay, here's what we know. M is the midpoint between A and D, and N is the midpoint between B and C. There's a couple of things that go with that. Whenever I have a mid-segment like this, what we know is that because it's a trapezoid already, AB and DC are parallel. That also means this. MN is parallel to them as well. Okay, so actually, if you look at this, we have a little trapezoid here on the top and a little trapezoid here on the bottom, along with the entire trapezoid that exists right there. The other thing that we know is that the length of the segment MN is actually the average of, if you take this base right here and add it to this base right here, and then divide by 2, then I find the length of the mid-segment, that is MN. So we're going to have a couple of problems that look like that, and then we'll be good. So let's take a look at these problems right here. Again, because I'm trying to find the length of the mid-segment right here, I'm going to take the 15 and the 25, add them together, and divide by 2. So in this one, we find that the length of M, or actually just the length of the mid-segment right there, is 20. Here's another way to look at it. Just find a place that's in the middle of 15 and 25. So the distance between 15 and 25 is 10. Well, what's half of 10? 5. So 25 minus 5 is 20, and 20 minus 5 is 15. This problem over here, that's example 4, is a little bit different. The reason that it's different is because I know the length of the mid-segment. Now I'm trying to find the length of one of the bases. So what I would do right here is I would not do algebra per se. I would find out what's the difference between 12 and 18. Well, it's obviously getting bigger, okay? So it's getting bigger this direction, but by how much? Well, this goes up plus 6. Well, because this is exactly in the middle, if it goes up 6 to get bigger, it must do what to get smaller? It's got to go minus 6. Okay, so the number is going to be the same. You just add and subtract it. So in this case right here, this distance right here, the length of the top base, is actually just 6, or 12 minus 6.